Hello, and welcome to the Tank Calibration Tank Strapping webinar. Here you will learn about various methods to assess the capacity or volume of a product that a storage tank holds. My name is Carrie Walter. I'm a marketing manager for Intertech Calibration USA, and with me is Daniel Murcia, Director of Sales and Marketing, Latin America and Calibration Americas. Our presenter for today is Mr. Daniel Sanchez. He is a chemical engineer who also holds a master's degree in science, and he specializes in oil and gas operations and metrology. Before starting our presentation, I'd like to review some items for the organization of the webinar. Please note that this presentation is being recorded and will be available for future playback on the Intertech website. All participants are configured to listen-only audio mode and will remain so for the duration of the seminar. To ask a question, click the Questions and Answer button on the right side of your screen. In the new panel that opens, type your question in the box and click Send Private. To retract your question after you've resent it, click the X Close icon. Feel free to submit your questions at any time during the presentation. We will answer all your questions during the question and answer session. The questions will be answered in order of arrival. Don't worry if due to time issues we're unable to answer your question, as we will send the answer to you in your email at the end of this webinar. Thank you for taking the time to join our tank calibration strapping webinar. Finally, don't forget to check your email in the next few days for a link to the recording. With that, I would like to start our presentation and introduce you to Mr. Daniel Sanchez. Daniel, please take the floor.
Good morning, everyone. Thank you very much for that introduction. I just wanted to take a moment and thank my friend Binod Kumar, who has been working in this content for a long time now, and that's been very helpful for this presentation. I just want to go over very quickly our agenda for this webinar. And first, we're going to start with the importance of tank calibration, why this should matter to tank operators and the oil and gas industry. Then we're going to move into the different methods of tank strapping and tank calibration. Then we're going to go over the sources of error and accuracy considerations when using laser scanning technologies. Then we're going to go over the technologies around tank calibration using laser scanning. And finally, we're going to talk about how Intertech is using the latest in technology and using the new technologies in tank calibration to create solutions that are cost effective for our clients and services that are cost effective for our clients. So first, we're going to talk about tank calibration importance in the oil and gas industry. And the way I like to do that is through an example. So let's say that you're currently holding 200,000 barrels of crude oil in a storage tank, and you are at the point of custody transfer. You're going to deliver that to your client. So how do you know that you have 200,000 barrels of crude oil? So what you do is you have your inventory control, and what it does is it measures the level within your tank. That's how we usually do it at the point of custody transfer. And so when you deliver to your client, he notices that there's 5,000 barrels of crude oil missing from your delivery. And so that is a problem that we face when we have inaccurate gauging tables at our disposal. Our inventory control and our loss control isn't correct. And we're opening our companies into unpleasant situations on the one hand, you could be underestimating your inventories and over delivering to your client, and so you are impacting your income. Or on the other hand, you're opening yourself up to disputes, claims, and possible litigations from your client towards you because you are under delivering the amount of product that you stated initially. So um, when you take these possible outcomes into consideration, you come to the conclusion that performing and maintaining proper tank calibrations within your facility, uh, the cost of these programs are minimal compared to the potential loss or the potential cost that some of these situations might make you incur. So the correct tank calibrations allow you to have more accurate measurements of your inventory and your inventory control and your loss control. And it also allows you to keep your customers happy because you are delivering the amount of product that they expect from you. So now we're going to go over some of the uh, process and the methods that we use for tank calibration. And I want, well, I want to point out that there are two types of tank calibration. One is volumetric and the other one is geometric. What we are going to see in this presentation is only the geometric side of the calibration. And all the methods that we use, be it strapping or laser technology, what they use or the principle behind them is always physical measurements of the tank or some of the properties of the tank, physical properties of the tank, to estimate via calculation, via computation, the volume and the actual volume of the tank and correlate that to level, to product level within the tank. So that's what we want to do when we calibrate a tank. We want to get an accurate correlation between level within the tank to total or actual volume of product. Some initial definitions, and we're going to talk about what deadwood is. Deadwood is anything within the tank or external to the tank that is going to affect our volume. That's tank internals and tank externals that is going to either add up to our actual volume or decrease our actual volume within the tank. So if you have piping, if you have heat exchangers within the tank or heating coils within the tank, that is going to deduct from our actual volume, and that is something that we have to consider when we are calibrating the tank, because it's going to be, it's like having ice in your drink. When you put in the ice, the level increases, but not because you are adding more beverage to your glass, but because all of this deadwood is displacing some of the volume of the liquid. And so that is something that we have to consider when we are calibrating a tank. And finally, the tank bottom is usually measured using either a setting of a laser station, total station in the floor of the tank, and then using that to estimate the volume of the bottom of the tank, which is below the rings of the tank. Or we use what we sometimes use is we use what we call combined method, and we use volumetric measurement of the bottom of the tank, and then we do geometric for the rest of the cylinder. Okay, and that is going to provide us with some reference points to accurately correlate level to volume, and also it's going to add up to our total actual volume of the tank. So some of the methods that we are going to cover in this presentation are, as I mentioned, they are geometrical methods, and The API defines these methods in the chapter 2 of its manual. And I like to think about the 2.2a method, which is the strapping method, as the father of all other methods. And that is not just because it was one of the first methods that we use, and that's because it comprises the physical measurement using a tape of the tank, but also because it has and it comprises all of the definitions and all of the calculations that you need to correlate the geometrical method that you are going to use later on to estimate cylinder volume to level. So what you do is all of the other methods that we see here, 2.2b, 2.2c, or 2.2d, we go all the way to J or H, if I recall correctly. All of those other methods are just methods for estimating the cylinder volume, but the 2.2a includes not only the cylinder volume estimation, but also the procedure for calculating every other property that you require for creating the gauging tables. So okay, so going over the cylinder volume estimation methods, the strapping method, as I mentioned, is the physical measurement using a tape of the circumference of the cylinder, and you do this. Well, a tank is constructed by rings, and rings are put on top of each other, and they're welded together. And so what you do is you take each of the rings of the tank, and you measure 20% from the bottom, 20% the height from the bottom, and then you measure the circumference at that point, and then you measure at 80% from the total height, and then you measure the circumference again, and then you do this for every ring in the tank. And so what you have to bear in mind with methods 2.2a and 2.2b is that you are going to have to personally have someone uh, going up and down the walls of the tank in order to move around the straps or move around the trolley that you use in method 2.2b in order to get the measurements that you require. And so that creates somehow a hazard for the people that are performing the activity, because they are working, in a very precarious position, hanging from the side of the tank. So method 2.2b is what we call the optical reference line method. And what you use is you pick a point in the first ring of the tank. Usually is the 80% of the height of the ring, and you measure the circumference, and then you use a magnetic trolley that you move around the side of the you move around the side of the wall of the tank. And what this trolley allows you to do is measure very accurately the warping around the wall of the tank in that vertical line. So you use the initial measurement as a reference, and then you see how much it deviates from that vertical line, that initial point. And that allows you to see the difference in circumference, or the difference in volume for each of the rings. And then you calculate an average circumference or an average diameter for each of the rings, and then you use that to estimate the total volume of the tank. Then we move on into what are the optical methods, and the 2.2c and the 2.2d are both optical. They use one uses a theodolite, and the 2.2d uses a laser station to create what this equipment does is it measures distance. So, and they use this to correlate and triangulate the volume of the tank. measuring several points within or external to the tank. The optical triangulation method uses a theodolite to create readings in each of the rings at different heights, and then you see the deviation in the shells of each of the rings. And then we go over into the internal electrical optical distance ranging method, which is the laser distance technology. And one of the advantages, or the laser ranging technology has many advantages, but one of the advantages that we have is that we have very, very good accuracy in and very precise measurements of distance, because it allows us an accuracy of 1/116th of an inch over a 600-foot distance. So that's very, very good for measuring. And so, and the other one of the other main advantages that it has is that we don't have to have scaffolding or people hanging from the roof of the tank in order to get the method done, or the procedure done. Uh, with the internal electrical optical distance method, you have the equipment inside the tank, so you do have to have the tank emptied, and operation needs to stop while the measurement is taking place, but it has the additional safety, the added safety in comparison with the traditional, let's say, methods. And now we're going to go over why and when do you have to calibrate or recalibrate your tank. And well, the API recommends that you recalibrate your tank when one of the following conditions happens. The first one is when you restore service to a tank that was previously disconnected or it was abandoned. And the reason why you do this is because even though tanks seem very, very solid structures, what happens is they shift and warp over time. And every time that you empty the tank and for a long period of time, and then you refill it, the pressure, the internal pressure of the liquid is going to cause some warping in the tank to occur. And that is the same thing that happens when you do the initial leak test of the tank. That's why when you have a new tank installed, you need to first do the leak testing before you can do the calibration, because the adding of the whatever product that you're using and filling the tank is going to warp it a little bit, and so the measurement is going to change a little bit. And so the second reason, or the second condition when you should recalibrate your tank, is when you deassemble it or re-erect it on you, or every time you move it. When you move it, you're going to create different discrepancies either in the walls of the tank, because you're not going to be perfect in your construction, and there's going to be a little bit of an offset, or you're going to maybe shift it a little bit on the vertical axis, and all of that is going to impact the accuracy of the level measurement, which ultimately is going to impact your inventory measurement, or the actual volume that you are holding within the tank. Also, whenever you do something that changes or affects the datum plate, which is the plate at the very bottom of the tank where you rest your gauging tape, or you change the reference point at the very top of the tank from where your tape is going to descend into the tank. When you change those the distance between those points related to each other, it's going to affect the measured volume within the tank. So then you should have it recalibrated. And also, whenever you do something that changes the deadwood, either increases or decreases the volume, the actual volume within the tank. Maybe you are going to remove some heating coils, maybe you are going to add some baffles, maybe you are going to add a mixer, whatever you are going to do with the tank, if it affects the actual volume, it's going to affect your tank calibration. So then you should redo the whole calibration for the tank. Also, the API recommends a particular frequency where you should do it. And so what they recommend is a 10 to 12 year interval for a full recalibration of the tank when the tank is operational and there is no other situation that might affect calibration. You should redo it every 10 to 12 years. And I just want to let you guys know that in Colombia, for example, when our customers have actually changed this recommendation to a 5-year cycle. And the reason why we do this is because the API also recommends that you have your tanks inspected every 5 years. And what you do in these inspections is you go out and you measure some of the rings and you measure the wall of the tank and you do most of the work that would that a complete recalibration would uh, require you to do. So and the outcome of those types of inspections is it's going to tell you whether you need to do an recalibration right now, or you can wait another 5 years and do it on the 10 to 12 year cycle. And so because of most of the work is the same, what some of our clients in America, in the Americas, have decided is it's just more cost effective and more accurate and better for them and their loss control programs to just redo the recalibrations every 5 years and just skip the inspection or just integrate that inspection into a full recalibration of the tank. And I think that's a very, very good practice to have because the better frequency or the faster frequency that you have between every recalibration, it's actually going to be better for you because it's going to allow you to keep better control of your intervals because you know that you have an accurate measurement of your tank volume. And this is also a loss control suggestion is that if you have or you experience significant variation or you are experiencing significant losses, continual losses, you should verify that your personnel or your inventory software is using the latest strapping chart because sometimes it can happen that you are using an incorrect or an incorrect gauging table, and then you are using or you are wasting some of the work that you've been doing by recalibrating the tank. So it's also a very good loss control suggestion to keep a very organized and very detailed strapping chart filing file system so that you can ensure that you are using the correct data. And we can see here what I was referring to before. This is what you would do when you are trying to estimate the level of a tank. What you do is you stand at the very top of the tank, and this is your reference point at the top. And then you would use your tape, which is the yellow thing that we can see here, and you go all the way down to the datum plate, and then you measure. You use your color cut or your milling paste to determine at which depth does your product end, and maybe if you have water, what's the level of the water, and then because water is usually going to accumulate at the bottom of the tank, and then you use another tape from your reference point, and you are going to use you're going to use that to measure the height at which your the level of your product begins, and then you're going to um, you're going to compare those measurements, and that's going to give you the level, the actual volume of product that you have within your tank. And some notes on the procedure that we use a laser procedure, and we use a rotating laser equipment to estimate the volume of the tank. And the reason we do that is because we have those equipments that are very accurate and very precise and in measuring, and so that's the kind of instruments that we offer to our clients. But we also have to note that the API has constructed these methodologies to be equivalent. You are going to, within a reasonable range of accuracy, you are going to get very similar results or very comparable results between the strapping method and whatever other method that you decide to use in your particular operation. And you also have to bear in mind, or you also have to consider that what you are using or what you are doing is correlating a length measurement, a measurement in length in one dimension to a volume, to a true volume in the storage tank. That's a three-dimensional measurement. So if you have an outdated or an inaccurate tank chart, it is going to impact negatively. It's going to have a cause and effect relationship between the inaccuracy of your chart and the inaccuracy of your inventory measurement and your true volume measurement. Because however, it doesn't matter how you actually measure your tank level, if you cannot correlate it accurately to volume, it doesn't matter how sophisticated your measurement system is. It's always going to have some level of error to your measurement, which is created by the gauging table. Sorry. So that is going to have an effect finally in your loss control for products. Now we are going to look and see, and we're going to focus more into the laser technologies that have been becoming more prominent in recent years as the technology has been getting considerably better. And that's one of the things that Intertech is has invested heavily is in creating tools that allowed it to use this new technology in a way that is better for our customers. And that's but we have to consider some let's say common things when you are undertaking a scanner, and that is you have to bear in mind that there's a limit to the capability of the scanner. All scanners, doesn't matter the model, some are better than others, but they all have a maximum inherent accuracy. So there is going to be an associated level of accuracy to your measurement. So well, this is more on the manufacturer of the equipment side. They have to control, and they have been very successful in controlling the accuracy of their equipment. Then there's the distortion and registration error, and this is more related to human error and how the data is registered, validated by the software or the person that is doing the field work or that is constructing the end product, which is the strapping table. It's that's more related to how the human operates and the human error and how we have good field practices, and that's something that Intertech has been very consistent and it's always looking for ways to improve their field practices and the field operations. And also the registration software has improved greatly in recent years. And this has allowed laser technologies to become much more mainstream and become much more accurate and safer than other technologies. The last thing you have to keep in mind is that the error propagates. If you have an error, let's say that you measure a point that is 1 millimeter off, and then you are trying to mesh this set of points. Uh, what you usually do, and we're going to get in a little bit more in depth in this later on the presentation, but what you usually do when you have laser equipment is that you pick a point within the tank, and then that's your reference point, that's your starting point. And then you create a cloud of points, of distances from that point to the wall of the tank or to the depth that you identified within the tank. And so that, and then you create this cloud of points, and then you from these multiple points, you create a 3D model of the tank. And then if your initial point is off by a couple of millimeters, and then you are trying to mesh your cloud, the first cloud of points that you measured, to another cloud of points within the tank. That is going to, and also that measurement has a little bit of an error. It's going to compound. All the errors are going to compound from all the measurements that you add in together. It's always going to add up to the error, to the final error of the procedure. So you have to have very good field practices in order to minimize the propagation of the error throughout the whole operation. And that leads us to talk about accuracy. And there are two types of accuracies that you have to identify within these types of procedures, and that is, one is global accuracy and the other one is site accuracy. The global accuracy is what I was referring to, and that is how good your data set or the data points that you've taken, or how much accuracy do they have related to your coordinate system, that is your base point. And the other one is site accuracy, which is it relates to how accurate one point towards the next that you measure is. So, or between across points within the site. So that relates to project accuracy and single scan accuracy. So the project accuracy relates to the global accuracy of the project, and that is how one point in, let's say that you have to make several measurements to get the full volume of the tank, and how the whole point cloud of points is going to relate to the other one, or the other points, or the other cloud of points that you are taking in a different section of the project. And then the single scan accuracy is related to the site accuracy, and that is how good your measurement is from one point relating to the other within the same scan. And so the single scan accuracy is actually on the manufacturer of the equipment. That's the only thing they can control. All the other errors are, even though they depend on single scan accuracy, they are also related to field practices and other things that happen in field, such as temperature, humidity. All of those things are going to factor in to the accuracy of the measurement. Let's say reflectivity of the surface, because that's maybe going to create reflections of the laser in several points, and that's going to maybe affect or create noise in your measurement. The angle of incidence, because that's going to have to do with refraction and reflection of the light in the surface. Also the color, because some colors are going to absorb more light or reflect more light, and that is also going to affect the accuracy of your measurements by creating noise, or maybe creating points where you can't measure properly. and also the range, and that relates to the equipment. How much further can you actually get excuse me, a correct measurement. Finally, well, some conclusions of what we have seen here is that these new technologies have allowed us to reduce the time that we spend in doing these operations from 3 hours to 1 hour. And you have to bear in mind that, for example, strapping is a very, very lengthy process. It's going to take you a long time because you need to physically measure the tape and put the tape around the cylinder of the tank throughout different stages of the tank. So that is going to take you maybe a day. And so what these methods are for is for reducing the time that we are on site acquiring the data. If we reduce the time that we are on site, we're also reducing the time that we spend in the case of inside measurements, such as the laser technology. We are going to reduce the time we spend in a confined space or in a hazardous situation. That is also good for us, good for our personnel, and it's also good for the client because we are going to reduce the operational disruption that comes along with these types of operations. And what we have tried to do at Intertech with our project, which is called ScanCal, is we have tried to automate the data acquisition and post-processing so that we reduce the human error that I was referring to before. As I mentioned, most of the accuracy depends on good field practices, and we have tried very, very hard to create a solution that allows us to automate these processes and so results in a better accuracy in the data that we collect. So and the other thing that we have done with the automated post-processing and better post-processing is the ability to make corrections and detect errors in the data and correct them before we move on with the process of creating the strapping table. And that's and we have also tried to create an app that is very user-friendly so that we can deliver to our clients data that is easy to interpret and easy to understand in the form of graphics and tables that is very useful for our clients, and we try to do it in a relatively short space of time. Now we're going to talk about laser technology in particular, and this is what I was referring to before. You can see here how we measure the different points using the laser theodolite located within the tank, and in order to create the cloud of points that I was referring within the tank. So we use a set of indications or recommendations by the API in chapter 2.2D to that indicate us the minimum number of points that we need to measure for each of the rings within the cylinder, and that is how we process. That is how we obtain the data that we later process into the strapping table. And usually you do it similarly to the way that you use the triangulation method, and it is that you measure at the 20% and the 80% of the height of each ring, and you measure the distance from the point, and that allows you to create and estimate the circumference of each of the rings. But what we are offering in addition to this method created by the API is all of the things that I have said previously about ScanCal, which is the automation and the good field practices that we use in order to minimize the errors and further enhance the methodology that is indicated in the standards. And this is what we get as an input to our models. What you see here in the curve is actually the deviations from the radius that we have estimated the cylinder to be in um, in each of the rings. So you see that there is some warping. This is very, very small, but you see some warping in the radius as you go up, and this goes inwards and outwards from the cylinder, and that is what we use. This is the type of measurements that we use to create the the actual strapping tables that we deliver to our customers. So as you can see, even though there are very minute differences between in the radius, in the radii of each of the rings, this is going to have a tremendous impact in the final volume of the tank. And all of this is done automatically by our software, but it also has the data QC to see if we have made errors, and that allows us to correct these errors while we are processing the data. And finally, that leads us to um, for me to show you how we are using this technology that I just presented you to create better services to our customers. And what we do is we take this sophisticated technology that is at the very cutting edge of technology, and we use it to create solutions that generate accurate data calibrations for tanks of several shapes. This technology is very versatile. We can do several types of tanks. We're going to see that later on, but we can do vertical and horizontal. We can do some of the things that you can't do with regular strapping, which is, for example, buried tanks, horizontal tanks, tanker trucks. We can use this technology because it's very versatile and very accurate, no matter the geometry of the tank, to create very useful and very precise calibration data. And we use these scanners for quicker and safer and lower impact solutions for strapping storage vessels. As I was saying, this allows us to translate these the full set of advantages of laser technology to our customers, and have I think that's the most important part, have safer operations overall. And this also allows us to comply with international standards such as ISO and API. So we get useful data, safer operations, and data that meets international standards. And just quickly, I want to mention our capabilities in tank calibration. We can do anything from independent storage facilities to large fuel terminals, oil refineries, power plants. If you have a tank that you need calibrated, it doesn't matter the size of type of tank. There's probably Intertek has the technology via laser or other methodologies to make it happen. And I know that I've covered mostly hydrocarbons and oil and gas, but actually these methodologies are not related to any type of particular products. These methodologies apply to any type of tank and any type of product. You can go from oil storage and refineries and refined products and lubricants and fuels to breweries, distilleries, soft drinks. We've done food, we've done milk storage tanks and milk storage facilities, water storage, animal feed storage. And as I was saying previously, we can do any we can do volumetric calibrations for any type of geometry that there's out there: vertical, horizontal, spherical, double wall, fixed roof, rotating roof. There's actually no limit to the versatility of these types of technology, and so we also have capabilities to provide surveys on tank settlement for vertical storage and tilt check. This is one of the things that happens when you move the tank or you intervene tanks, or you do operations on tanks or existing tanks. You create deviations on tilt, and that's one of the reasons why you have to have your tanks recalibrated. So we do these inspections that allows us to assure our clients and assure their clients that the gauging tables that they're using are correct, and the volume that they're using and their measurements are correct. We can also check for tank shell roundness and seal surveys for vessels with a floating roof. So that is also going to contribute to your loss control. So I think that concludes our presentation for the day. And I just want to, I know there's some questions from the audience, so I just want to get in on that. Thank you very much.
We have some questions that came in. What is the most popular and accurate method that you use for tank strapping?
Okay, so as I was saying previously, the API has devised these methodologies so that all results are comparable, whether you are using laser technology or strapping methods or any other methods that your operation needs. The results are going to be comparable within a level of accuracy. So, but regarding the most popular, it, in my experience in the Americas, one of the most popular methods is still strapping. I think it has major popularity because it's a very reliable method and people know it very well. But I think with the new technologies that are coming out and the greater accuracy from the laser technologies, that they're going to become very, very relevant in the near future for tank calibration.
Perfect. I have another question that's come in. This person writes, I have continuous volume loss in one of my tanks. Should I have it restrapped?
Yes, one of the reasons that you might have continuous volume loss is because either your strapping tables are out of date, or you're using the improper ones, or there's been some modification to your tank, maybe some warping or maybe some dead wood. It's been modified, and or maybe the tank has tilted a little bit, and that creates a difference between what you measure and what you actually have. And so what I would recommend is have it restrapped to generate a new table that is representative of the current state of your tank, and that should help you reduce the volume loss.
Okay. We have another question. In what areas or countries do you perform tank strapping?
Okay, well, speaking only about the Americas, we have capabilities in Colombia and Chile, Argentina. We have the US, some places in the Caribbean, Canada. Well, the Intertech the Intertech group and Calibrate in particular is very widespread. We have over 1,000 locations across the globe, and we have tank calibration capabilities in many of those locations. So we have presence across the globe.
Thank you. Here's another one. This person writes, during recent bad weather, my tank was badly damaged. Do I need to recalibrate it after the repair is completed?
Yes, as I was saying previously, you should always recalibrate your tank when you do or you perform any modifications to it, and that includes repair, because there's going to be small differences in construction every time that you weld and every time that you for example, weld a new sheet into one of the rings. There's going to be a little bit of a give between what was previously and what you have now, and so this is going to create a difference in the gauging table that you have. So in order to have a strapping table that is accurate, you are going to have to perform the repair and then do the testing, the leak test, and then after that you've done the leak test, you can proceed with the tank calibration, because I think I maybe mentioned this previously, the leak test, when you fill the tank with water, that is also going to create some warping in the tank, and that is also going to affect calibration. So you have to wait until everything is completed until you recalibrate your tank, but you do have to do it after you are finished with the repair.
Thank you. I have another question. This person writes, I have a new customer and we will be changing the product from black oil to a clean product. Should I recalibrate my tank after cleaning?
Well, as I mentioned to you during the presentation, what you are doing with a strapping table or a gauging table is you are translating a one-dimensional measurement, which is length or height, into a three-dimensional measurement, which is volume. And so what you are doing to make this calculation, or what you are assuming to do this calculation, is density, product density. So strapping tables are related to product density that is in the tank, of the product that is in the tank. So if you change the products, the very least that you have to do is have your strapping tables recalculated to incorporate that new density of the product that you are going to be storing in the tank in the future. So even though you don't, it would be recommendable to recalibrate the tank. You don't actually have to do it if you haven't done anything that would affect the volume of the tank, but you at least have to have your strapping tables recalculated.
Okay, thank you. I see that we have a few more questions, but due to time that we allotted for this webinar, they will be answered by email. Please feel free to contact us on the on-screen email, and any questions that came in that we didn't address during the webinar, we will send you an email reply. I'd like to thank everybody for your time today, and that concludes our webinar. Thank you.
Thank you very much.